So this video will focus on decomposition of functions as well as graphing compositions of functions. So if we just take a look at this, so we're going to start off here of k of p of x, right? So it is already giving you a function that has been combined, right? So it has been composed. So if we look at this here, right, we're going to say, okay, well, what would p of x be? What is the inside function? And on problems like this at the beginning, it kind of looks familiar. It looks like you could just quickly pick out, okay, well, 4x minus 9 looks to be the inside, right? That looks to be that inside part. And remember from when we were combining the functions, right, we would say, well, whatever the inside function was, replace the x on the original function. So we can say the original function here is 3x squared plus 2. And because what we would have done, so let's see if we got this right. If we went to find k of p of x, we would have said 3, 4x minus 9 squared plus 2. So you see that this ends up matching where we started, so we know that those two are correct. And this is your most basic form of this, right, is we had to do this. A couple things that we just want to break down is, one, we aren't allowed to use the identity function. So you can't just call something, right, no function can be x, right? No function can just be x. Then, so that's the first part, okay? The other part, so let's step over here and say, okay, well, what hints could we help ourselves with? So one is we just need to pick a factor or an inside function. Factor, maybe an inside function. So in this case, right, there's always multiple answers to one of these questions. So in this one, we picked the inside function. That is one answer. That's what we had. Okay. Then in the original function, we want to replace the factor with x in the original function. Okay, then we want to plug it back in to test, right? Then we want to test to make sure we got it right. And if we didn't, then we want to just retry. Didn't work. So for right now, I just ask that you kind of hang on with this for a moment because it is a little bit confusing. Some are much easier than others, but we want to make sure we try a bunch of these to get there. So let's look at this next one. Okay, so one example would be 2x minus 9 as the inside, right? Then what it says, replace that factor, the 2x minus 9, with x. So our outside would be 3 over x. Now if we want to combine that, again, these look pretty simple. We replace the x with 2x minus 9, and you see this matches where we started, so those two are good. Now, if we look at part C here, we want to look at this and say, okay, inside. Well, what if we made the inside x minus 3? That works. Okay, then I could say, okay, well, 5 over x plus 10. Now you could check that and say, well, 5 over, replace x with our inside function, and there we go. Okay. Well, this is an example. This is a good one where there is another answer that could be easily reached. So you could pause the video for a second, see if you could come up with another p of x and another k of x that would work for this problem. Okay, hopefully you found one, but if you didn't, right, what if we said, okay, 5 over x minus 3 for that? What if that was our new inside? Well, our outside then would have been x plus 10. Right? And again, if you wanted to try to solve it, you would say, okay, well, 5, or replace to check to make sure I got it right. You see that it works when you replace p of x in for the x's. Okay, you'll see D, okay, part D. So let's see here. What do we want to use? Well, we could do it a couple different ways again. So I'm just going to choose one to start. What if we did x plus 3? Then this guy is the square root of x squared minus 12. Again, you could check, well, if you do plug that in, you still get x plus 3 squared minus 12. which is where we started. So again, pause the video, see if you can come up with another answer. So hopefully you found another one. What if we said this time we did x plus 3 squared minus 12 as p of x? That could have left as k of x as the square root of x. Now, again, this isn't the only way to do it. There could have been lots of others, but this is one way. Okay, then we get to E. So on part E, we could see a bunch of different ways, right? This is one where there's plenty of them. Okay, so one way we talked about in a different class was we said, okay, well, what if we rearrange this into 6 plus absolute value of x minus x? We didn't change the function at all. All we've done is rearrange it. And then they said, well, what if the inside function was x, absolute value of x minus x? Well, if we replaced that with x, we would just have 6 plus x. So if you want to, pause the video, try to come up with another inside and then what the outside would look like. So hopefully you were able to come up with another one. I'm going to look at this one now. What if we said the inside was absolute value of x minus x plus 3? So now this breaks it down a little bit more. And this is what makes it a little hard is, okay, well, if you see from here, we already had that broken down. And what would we need to break out? Well, what if we said it was 3 plus absolute value of x minus x? Right? Well, now this is the part we just looked at. And so what you would be left with is 3 plus x. Okay. Now, okay, you look at that and you say, aren't we making this more complicated than it could be? Yes, in this instance, but that idea might help us out. So let's look at f. All right. A couple of different ways to do this as well. So what if we start here? Okay, we've been seeming to use the denominator a lot of times. So what if we did 7 plus x? Okay. So if we did 7 plus x, you look at it here, you replace that. So we know on the bottom, that's just going to be x. Well, in the top, if I know the top had to be originally 4 plus x, and I know that somehow I want a 7 plus x factor, what do we need in the top? We also need a minus 3, because 7 minus 3 would give me the 4 that I'm looking for up top. So this now would become x minus 3. Now this is the perfect time. In problems like this, it started to become more ambiguous on whether you're actually getting the right thing. So this is where coming in to check your work is good. So we would then replace x with 7 plus x minus 3 over 7 plus x. So the top would become x plus 4, and the bottom would remain 7 plus x, which is where we started, so we know our two are good. Okay. So here's my challenge to you is this time, what if you did x plus 4 as the factor, as p of x? What would k of x be? So pause the video, try to find k of x. So hopefully you found that. Okay, so now we know that the top part would have been x. The bottom, we would have had x plus 7 is what we needed, and we were going to need a factor of x plus 4. Well, we would just have to add 3 because we needed there to be a 7. So this would be x plus 3. Again, we could check that. We got x plus 4 over x plus 4 plus 3. So x plus 4 over x plus 7. And then finally, there is a problem here where it's saying we have 3 groups, right? So what's the inside most here? X squared minus 7. Then we could get to the next part, cube root of x. And then the last part, 5 over x. And what we could look at here is if we get that inside part, we would have had here going in between them 5 over cube root of x. So from here, that went there. That helps me find this. And then that would have helped me find that guy. So I'm going to stop the video here. I'm going to have you try the problems on page 56, more decomposition, so you can work through those. check the answers, and then I'll join you on the next video to talk about the graphs.